Right now, inside the device you're watching this on, there are more of these than there are stars you can see in the night sky. Billions of them. In a single phone. And you have never seen one because each one is smaller than a virus. It's called the Transistor. It's the most manufactured object in human history. We've made more of them than every grain of sand, every ant, and every star in our galaxy combined. And almost nobody can tell you what it actually is. This is the story of the most important invention you've never thought about and the strange way it accidentally created Silicon Valley. Picture a computer so big it needs its own room. Not a closet, not a corner, an entire room. That was ENIAC. Built in the 1940s, weighing in at around 30 tons and stretching over 1,800 square feet. Its guts were about 18,000 glass vacuum tubes, each one glowing hot like a tiny light bulb, stacked in endless rows. These tubes were not just bulky, they were power-hungry, each one drawing up to 8 watts, and together guzzling 150,000 watts. The heat pouring off them could roast you if you stood too close. To keep ENIAC from melting down, engineers ran giant air conditioners day and night, but the real headache was not the power bill. It was the constant breakdowns. Tubes burned out so often that teams of technicians patrolled the machine around the clock, hunting for the next failure. On a good week, they would swap out a dozen tubes. On a bad day, a single glitch could bring the whole system to a halt. Finding the bad tube meant wading through a maze of wires and sockets, pulling out glass cylinders one by one, hoping the next replacement would hold. Some days, ENIAC was more hospital patient than computer. The sheer scale, the heat, the non-stop repairs, every bit of it screamed for something better, and that pressure was building to a breaking point. Inside a cramped Bell Labs lab in December 1947, 2 scientists hunched over a slab of germanium, a pair of gold wires, and a handful of hope. John Bardeen and Walter Bratton weren't working with glowing tubes or heavy machinery, just a fingertip-sized piece of crystal and tools so simple they could fit in a pocket. They pressed 2 gold contacts onto the surface, forming what looked like a tiny arrowhead. Then they wired up a microphone and a speaker. When Bardeen whispered hello into the microphone, the speaker blasted it back, loud and clear. This was amplification without a single vacuum tube. The device was called a point-contact transistor. It could switch and amplify electrical signals, but it didn't need to heat up, didn't burn out, and ran cool to the touch. In that moment, the old rules of electronics were broken. A room full of tubes had been replaced by something you could lose between your fingers. Brattain and Bardeen's experiment was more than a lab trick. Within weeks, Bell Labs moved to patent the invention. Shockley's name appeared on the papers too, though he hadn't been at the bench that day. The Nobel Committee took notice. In 1956, all 3 men, Bardeen, Brattain, and Shockley, shared the Nobel Prize in Physics for a discovery that would ripple through every corner of modern life. William Shockley didn't just want to invent, he wanted to lead. After the transistor breakthrough, he packed up his ambition and headed west, setting up Shockley Semiconductor Laboratory in California. The plan was to build a team to push solid-state electronics even further. But inside those walls, something strange happened. Shockley, once a visionary, became rigid and suspicious. He tracked employees' movements, hid research directions, and refused to share credit. The lab filled with tension instead of trust. 8 of his brightest engineers, including Robert Noyce and Gordon Moore, had enough. In 1957, they walked out together, earning the nickname the Traitorous 8. They weren't just quitting a job, they were starting a revolution. They launched Fairchild Semiconductor. This was the seed that would sprout Silicon Valley. Fairchild didn't just make better transistors, they built a culture of risk, invention, and rapid growth. Alumni fanned out to start new ventures, including Intel. The irony is hard to miss. Shockley's quest for control triggered a wave of independence that turned a sleepy California valley into the world's tech capital. Subscribe for more stories where tiny inventions change everything. A transistor is a switch. That is a switch so small you could line up thousands across the width of a single human hair. Instead of glass and filaments, it is made from a slice of silicon, a few atoms thick, with layers arranged to let electricity flow or stop cold, all at the flick of a signal. That flick can mean amplifying a whisper into a shout, or flipping a bit from 0 to 1. Every app, every photo, every call, it all comes down to these microscopic gatekeepers opening and closing billions of times per second. Today, the scale is almost impossible to picture. The latest chips in your phone pack in 15 to 20 billion transistors just in that tiny square under the case. Each one measures about 5 nanometers across. That is smaller than a virus, smaller than the wavelength of visible light. Industry estimates say humans have manufactured around 13 sextillion transistors. 13 followed by 21 zeros. That is more switches than there are grains of sand on Earth, or stars in the known universe. The world runs on a sea of invisible, silent switches flipping in the dark, making everything work while we barely notice. Every second, trillions of tiny transistors switch on and off, powering every moment of modern life. Sometimes the world changes forever, and you never even see it. Subscribe for more incredible stories.